So welcome everybody, and welcome Sergio to this part of our lecture on natural building system or ecological building system. And
Yes.
I'm really happy to host you here because when I was looking for some examples of mud brick building around the world, I was really happy to see one of the house you have been building, especially that it is in Mexico, so a country that has very big earthquake happening quite often. The same situation as Turkey, but still trying to work with those natural materials that everybody is telling are not suitable for earthquakes. So I was really happy to find some examples of such building, and I'm really happy that you accepted to share your experience in our class. So if you want to introduce yourself, I will be very happy, and then you can present your work.
I'm Sergio Portillo. I'm from Mexico City. I studied architecture a while ago, about I believe 18 years ago. Graduated from the University of Ibero-American University. I directed an office for 12 years and a construction company, and then 6 years ago I decided to open my own firm. From which the main idea of was to do architecture based mainly in with a big relationship to the place, to its own place, and to the site, to specific sites. So in a way we're kind of we're looking for that. Through these 6 years, we've been doing different kinds of projects, and all of them we try to have all of them with different approaches, but we try to have a common factor that is to thrive for a sense of place. On the matter of this seminar, I will talk about one specific project. It's a house that we made. It's one of the first projects we did in the office. And well, since we all of our works, we try to understand mainly the place where we're doing them, the site. We visit the site, and then for us, it's very important to understand and to start a constant communication and investigation with a constant relationship with the context. So for us, it's very important, this. And one of the first things, I'm going to start with my presentation. This is the site. Casa Cumbres, or Cumbres House, is located west of Mexico City. And it's inside a residential complex with consecutive housing chain, and restrictions where the separation between houses is kind of reduced. But as you can see here, mostly these are this is the way in, and most of the houses have these restrictions at the front and at the back, and they have little restrictions of the sides. So I'm going to speak to you a little bit about the project and how we got to it. This is the site. Sorry about the picture, we didn't find any in color. But as you can see, most of the houses, and I think you'll see in the future picture, most of the houses, well, except this one. This one, of course, has all its windows are looking for the houses, for the Calendant houses. So that brings some trouble for the people living here. But most of them have windows looking outside to this street, and most of them have, all the times, they have their shades down, because well, they don't want to be looking all the time at cars and everything. So on one of the first visits we made to the site, this is what we saw. We well, the complex makes every construction site has to have its own mesh wall to separate to the sites, the working sites. So we had to do this, but this inside is this is the site of the work, and this is very. I wanted to have this picture because this is mainly where the concept of working, or the idea of working with earth came to me. I wanted to kind of to keep the sense of this place and to make something of it. Seeing this with the people of the earth, the people that study earth, we saw that this kind of material had very good qualities, and so some from here, and another something else was this was kind of the limitations we had and the restrictions, and we had to take out a lot of ground earth to build this house. So that represented a high cost as well. So that's when I started investigating what could we do with the soil of the site, with the earth. And we started to working with some options for the program. See, everyone had to, like, most of the houses were looking at the street, and we wanted to kind of have an interior openness scheme where the house would open to the inside rather than the outside, which in this case was the street. So we came with this idea of taking the earth, or this part of the land, and making it, well, during this investigation we did working with earth, one of the best solutions was we found to be compressed earth blocks, because mostly the kind of the project we were doing, we saw some other alternatives to working with earth, but for this kind of project, compressed earth blocks made sense to try to do those. So I'm going to speak to you a little bit about the project really fast, because I think we don't have that much time, but we have 3 levels. The house is developed in 3 levels. We have the basement with a garage and services, and we have over here a kind of place for earth. So we have a large tree in the upper level over here. We have at the patio, so we had to leave like this kind of giant pot to have that tree. And then we have the services areas, and we have the option to go to the upper floor from over here. Then we have the main entrance area, where we have the more public spaces. We have a main door entrance. We have a large. The project is divided into 2 patios: the central one and the back one, and the back patio. And most of this level, most of the things happening at this level, the idea was to open this plan completely, so we could have an open floor plan here. So all the spaces connect within these 2 patios. But this facade is more closed to the outside. Then we have the upper floor, where we can find 3 bedrooms, the master one and other 2, and two other bedrooms, and a place for watching a TV room. So this was what we wanted to do. The concept became then, since we were working with Earth, I guess the concept was to how could we make a connection between what we wanted to do, which was a house, and the main material which we were using. So so we gave it this appearance of an extruded block. The house has this appearance of extrusion, and which looks like very closed and hermetic from the outside, and then we wanted to have this openness in the inside. This was one of the renderings we made. These were the first renderings we made for this, and then you could see from the model it looked like a block, or like a box with very little openings in the outside, but most of them were happening in the inside. So this is the construction site. Well, it was a bit taking the decision or making the decision of working with Earth was a bit complicated for me, because first of all, I hadn't worked with Earth before with this kind of technique. So I through the investigation, I contacted some friends from Guadalajara in Mexico, and then I started seeing. We did this house in 1916. Well, we started it 1915. Sorry, 2015, and so there wasn't that much information here in Mexico that I could find. There were some cases already, so I tried to reach them, and I found some in Guadalajara. And what we did was we brought a machine, a compressed. It was kind of a compressor, actually, that we brought from Guadalajara, and they helped us with the process. But obviously, the process was to remove to use the same earth from the land, and to start working with the blocks. The thing is, the procedure was a bit slow, because first of all, as you said before, Mexico is a city that it's a large, has a quite continuous activity of earthquakes, and actually I know you guys had one very recent, but we've had some major earthquakes. We had one in 1957, and when we have a very big one in 1985, which was 8 points, and then we had one very recently. Actually, the house was already built, and I'll tell you about in a bit. But it behaved very well. So in that saying that about earthquakes, the process of making these blocks was kind of how do you say trial error process, and we have to make like different recipes. The guys from Guadalajara told us this was the way we should do it, and we had to find, basically what we needed was to make a block that could find the resistance of a regular cement block, or a regular block, which was 70 kilograms per square centimeter. And in order to find or to get to this resistance, we had to make different recipes for this blocks. And in order to do that, we needed to take obviously some of the earth from the ground to start making our trials. So this is we had to take some of the land out. We had to take the green part out, the vegetable part we took out of the site. And then what I did from the beginning was I asked for, and this line right here is the limit of our site. And I asked the neighbor. I had to make a letter for the neighbor to ask to borrow while we were doing the construction works, to borrow a bit of his land, so I could have a little more space, because we soon found out that space was going to be a problem, and actually space and time was something we found out was going to be something we were going to deal with in the process of making earth blocks. So we took the earth and we started making some samples. Actually, I was impressed with the first sample. The first like very easy tests that the guy from Guadalajara did with us. He took a like. I thought he was going to do like something very technological or something with this, but it actually was very simple and kind of artisan with it. So he took a little bit of the earth and he added some water, and then he made a little ball with it, and he said if it breaks within sometimes, your earth has very good qualities, and if it doesn't, we should add some more stabilizers or some other procedures to establish it. So this was kind of interesting. While we were doing this, while we were taking the ground off, we had to start working on the basis of the construction site. And so what we're doing here is this is the neighbor's house, and we needed to make here the first concrete element part of the construction. And what we did, we started taking this earth and making some tries. We had to stabilize it with cement. Then it's kind of tradition to, I want to include this picture because it's kind of tradition when you start a construction here in Mexico to kind of make a bit of a celebration. So as you can see, even with the works, what we did was we did some carnitas tacos here at site. Some of the people that were at the site. So, ¿me checas cómo es la traducción de cimentación? So, right here we're doing this first concrete element that was what had to support the earth under the neighbor's house. As you can see here, we already added the metal rods, the structure for the foundation. Sorry about that. And we had to do this in different stages. So we had to open like a limited area and then we would open, we would leave the earth between this one and the other one, and we open another one to continue working with this concrete foundation that we had to do. So we started the openings for the foundation, which was mostly concrete and reinforced concrete. As you'll see, the structure project, the structural project for this, it was a regular it was a regular structure. It was concrete, reinforced concrete structure for all the house, because we had to do, we had some big areas that, and you'll see along how we managed to put the earth blocks along with the reinforced concrete for the structure, the structural part. So this was the site, and as you can see here, you can see here we had to manage with space. This is the extra, the spare space we asked for the neighbor. Our actual site closed over here, right where it says 1 right here, and we were working on the foundation, while at the same time what made it more complex was that we had a construction site, but we had to make space for a production line. So soon I found out that was going to be not so easy, and so what we did here is we had this production site here. We started making the blocks in this part of the site. We bought this machine to get the earth as thin as it needed to be for making the blocks, the earth blocks. And then from this we had someone here making it thinner. Then, as you can see here, it got thin enough, and then we had someone else with a second tool, keeping the big rocks out and making it as thin as we wanted here. And then here we made the mixtures. As you can see, it's not so elaborated. It's kind of artisan work, and we made the mixtures here. Then we had the machine that we brought, that it only had two spaces to make blocks, so we started making them. And then here at the same site, we laid them on the sun to dry. But this wasn't the only process we had to do. We had to do different kinds of recipes of these blocks, and we had to send them to a laboratory. And then at the laboratory, we had different times to see if we were reaching the correct strength of each one. So we had to check on we had 3 different dates. So we have to check day 8, and then on the I believe it was on the 6th. Then on the 12th day, we would see how a specific recipe was doing, and then at the 24th day, it was going to be reaching most of its strength or its capacity. So that took us some time to find the correct recipe. It took a bit of time, and that was kind of stressing. while because we had the construction going, and we couldn't stop this here, and at the same time we needed to see what we needed to find the correct structural we needed to get the blocks on to get the strength they needed. Okay, so here we are working with the earth, with the thin part of the earth. Then we made the mixtures here. Most of the mixtures was we added about 4 to 6% of cement. Then we added 7% approximately of lime. Then we added 12% of sand, and the rest was the earth of the site, which is a ground called tepetate, which has this very good proportions and qualities for doing adobe. So these are our first recipes, our first testings. So what we did here, as you can see, we put numbers on them. We numbered them so we could find out which was the one that was getting the resistance we needed to. So as you can see, this is number 12, and I think we did like 17 different recipes, because first because we were below, and then we did some that were above from them. Then we had to do the middle of it, and then till it got to the point where we got to the resistance we needed to get to. I'm going to put a video so you guys can see the first. I don't know. Can you hear me right there? Just checking.
Yeah, we can hear you. Just
okay, great.
No problem.
Okay.
I'm waiting for the video. No problem.
Okay. So this is a short video. You can see the
yeah, we can see
the machine here. This was actually one of the first attempts for us trying. We were actually trying the machine. Okay, so as you can see, that was one of the first attempts of making these blocks, and then we continued with the process of trial and error with the laboratory people. Here they're visiting one of the visits they did, and we were making the calculations on site to see how many all the recipes depended on specific percentages and bucket wise on any of these materials. So the thing is that's the thing we were working with. These are the blocks laying to the sun. We needed to do about 200 blocks per day, and I think we managed to do like 130 blocks daily, I believe. And so that was the thing that was most stressing, working kind of against time. As you can see, they're not perfect blocks, but they work perfectly once we got to the desired strength or resistance we wanted to accomplish. So here you can see we started once we found the resistancy that we wanted. We found a recipe, and we got rid of the ones that weren't getting to that didn't have the strength or the resistancy of we needed. We used them someplace else in the house, and then we started using them right here. We started building the bottom floor. As you can see here, we have already some progress in the grounding floor, the foundation. Then the house started rising. The joints with the conventional construction solution, which was reinforced concrete, worked okay. We were worried about future cracks between these two elements, since we were told they would move or work differently, but we didn't get that problem at all. Kind of the we poured concrete on these parts with the wooden framework that this castles use, or this structural element use, and it worked okay. For some parts, we added some metal grid, like small metal mesh, and to add that, because further we saw that where we had bigger than 3 meters of space between these two elements, we started to find out that we were getting some cracks in the middle. So what we saw that from the beginning, and so we started making we added some more structural elements in the middle, and we sorted that out. We could see here some of the wooden formwork for the upper ground level. Okay. Here we can see from another angle how the walls are becoming. We added some regular red ¿cómo se dice?
Tiles.
Yes, for some of the parts where we were going to have contact with water. That's one of the things we wanted to. You have to, when you work with earth blocks, what you need to do is to the enemy is water. So the parts we knew that were going to be in constant part with some with some of constant like the grounding. So like the first the bottoms of some parts of the house, we added some of these, but mostly it was used with mostly we did with earth blocks. As you can see back here, you can see everything. We have like the construction site here, and back here we had the fabrication process, and then as well we had the same we had stock here, and then back here we had some more blocks. So that was the main thing we had to manage. Space. We were working quite tight with as you can see here. So tight we had to make this kind of system to keep some of the wood and to keep materials and to make space or to make room for us to keep working. Here we were doing the reinforcement for the concrete slabs. So you can see that's going to be the next level floor. We're pouring here the cement for that part. Then the house started to rise from that level as well. And here you can see what we started to see during the process of this construction was we started to see some cracks in the middle of some of these. I believe it was in another part of the house. Like we had a bigger distance from here that the structural engineer, the structural project had bigger separations from these structural elements, and we started to see like cracks in the middle. So because once this, and we started seeing those once the sun started hitting them hard, and so what we did was we closed the distance between these two elements, and the problem got fixed. Then this is an interior as well as a house. For example, here we had a pile of water, so we needed to do it on concrete, and so the parts of the house that were going to be like this, there were going to be constant like water. We needed to separate them from the earth blocks. This is the same space we used the same clay, the same earth to do this. So we use this we use the same earth, the same ground to add here, and we flattened it, and then we added these separations. They were part of the concept. These lines we added here worked for two reasons, actually for three. They were part of the concept as we wanted to do this extrusion effect on the house, and it helped us as well for possible like minimum cracks we would expect. And so they would, if you would get like a minimum crack for let me find the word. I'm sorry.
For the plaster.
Yes. For the regular settlements of the house, we knew we were going to get like some minimum, like with the settlements, some minimum cracks, and not structural, but superficial. So these separations helped us with that. And also we started to seeing once we get that flattened earth flattened around the house, in the inside and in the outside and the inside, we started to see how the house started to get like its own life, its own color. Water, the walls took some time to dry, and some of these they kept in colors. So since they're natural material, it started to giving like a sense of. I think the house began to have like its own life, and then at the different times of the day, you would get like kind of different environments with the different lights. You can see here how we flattened with the structural parts, the structural elements, as well as the earth blocks ones. This is the staircase we made, and how it looked from the inside once we started giving it this flattened material with the earth. You can see here the structural concrete beam we had here, the structural elements, the patio. Then this was the finished house, and you can see here how you get this. Like this has one tone, and this has another, and this right here has another, and then in that sense, the house has like its own character, which we believe it's quite personal. It gives like a sense of belonging to the site, because we in that sense we don't choose the color of the house, but the site or the place gives it its own personality and its own character and its own. We believe it belongs better to the site. This is one of the interiors. We just used regular flattened white lime for the interiors. This is the stair. This is the first. This right here is the first. The concrete wall that comes. The first one we started seeing from the very beginning. It's one of these. This part right here of the house. And you can see how it behaves and how it gives quite some character to the house. The color and through time, it's been 5 years since we finished this house. A little more than 4 years actually, and we visited recently after the recent earthquake, and the walls are perfect. It has behaved very well. The settlements have been more like in the inside. Some parts we've done some maintenance work, but most of it, the house behaves wonderfully, and it has some really good characteristics with climate as well, because it's when it's cold outside, the house keeps warm, and when it's hot outside, the house it keeps cool. So in that sense, it's also very energy efficient as well. And we like this picture because it reminds me of the first time I visited the site, and the concept, and what we wanted to do with the earth, and what we could do, what the earth of the site could become. So we came quite happy. That's it. Thank you very much.
Thanks a lot. Thanks a lot for this beautiful project using, I'm sure it has been, and we can hear it has been quite a challenge to use directly the earth of the site, directly in the construction, and producing all those bricks at this place where they were used, where they will be used. The site is so narrow that really well done to have done it, because I know about earth construction. I know how much space it is taking to produce bricks. And yes, I'm sure it was quite challenging. But at the end, it's a really beautiful project that you managed to do. So thanks a lot for sharing it.
No, thank you.
I have one question, actually,
Yes.
for starting. I'm sure students will have more questions if you have time.
Yes, sure.
My question is, you didn't do anything special for earthquake resistance that would not have been done with any other material. If you would have used normal concrete blocks, you would have done exactly the same construction, or is there anything special?
Well, actually, while working with structural engineers, what we did was this is one important thing. Earth block was actually heavier. Turns out to be heavier than the whole cement block that the regular one, because
Yeah.
the one, it has like a hole is in the middle, so it's
Yes.
It's hollow, and so we had to. He calculated that extra weight for the house. To be completely honest, this was the first time I was doing this, and I was working with the earth. I wanted to do it because I knew all of its efficiency factors and all of its good parts, but it also worried me on the other part. To the structural part worried me a lot, and I can tell you now, 4 years later, that I think it has worked and behaved better than regular construction materials, because I think it adapts better. And in that sense, when we went to visit the house after the last 19 on the 17th, we had a major earthquake as well, and we went to see the house to see how it behaved, and it behaved wonderfully. There were no. I can tell you, there were no cracks at the physical walls for the facade. So even at I was thinking that the plaster was going to be like some superficial cracks or something for the settlements, but there weren't. We found some in other parts of the house. In the inside, we found some, but they were very superficial and mostly none of them, nothing important. So I can tell you, the material works better than I expected. Even though we had a conventional reinforced concrete structure working with this, and obviously here in Mexico we had some since 1985 for the big earthquake we had. There were some increases of minimums for the structural elements and structural projects that you have to do, and then there were from that part there were some arrangements that were done to what you can construct for the minimum strengths approved. And then I think after 2017 there were some other it got even you needed to do from the last earthquake. I think they went a bit higher for the resistance minimum procedures and for the responsibilities of this kind of constructions. I don't know if I answered your.
Yes. I mean, yes, I understood. And it's also, I was asking because, okay, I know about this type of structure, but this confined masonry, I mean, the way the walls were built and after you are making the columns and the beam with concrete is totally different of what is done usually in Turkey. In Turkey, in all buildings, they will start to build columns and beams and then put the masonry inside. But here in Mexico, probably you're doing another type of masonry, and that's the reason why I was asking about it. I know about it, but the students here will not know about this type of construction. That's also the question.
Well, it actually helped doing it that way because, as you can see in one of the pictures, when we first did the block wall,
yeah,
the earth wall, and then we leave the metal rods for the structural element, and then then you just put like the wooden frame one side on the other, and then that allows for the concrete to get in those little small spaces for the blocks.
Yes.
And I think that helped. I think that helped specifically for this.
Yeah,
for this
exactly.
project.
It is something that is quite new, and in the new earthquake code of Turkey, it's finally allowed. But it's something students they don't know. That's the reason why it's really interesting. It's really interesting to see this project here. That's the reason why I'm specifically speaking about it.
Yes.
Oh,
yes. So that's how we did.
Yeah, and you had also some horizontal beams in the middle of the wall, isn't it?
Yes, we did. We added some in the intermediate, specifically because I was worried about this cracks that we were finding out, and also this, I have to tell you, this was kind of new as well for the structural engineer we were working with. Working with earth was kind of, he knew about it. It's like something he has knew for some time, but he has never done it. And to tell you the truth, we didn't find someone who knew about it. Probably now there are more people involved in this and that know much more about structural elements to go with earth. But at this time, we didn't know that much, so we rather went for the secure option, and I think it worked perfectly. I think in Mexico we have this great opportunity. And I think as well as in Turkey, that craftsmanship and labor is very good quality. We have very good quality of labor here, and that allows us and at a reasonable price, at a reasonable cost. So that allows us to that gives us an opportunity to go and do these kinds of things, and to try to give that extra step in finding out different materials and different techniques. And so in that way, I think it helped a lot.
Okay, thanks. There is Aisha that is asking if you can explain a bit more about the plaster you used outside, how it behaves with rain, and if the owners need to do anything for the maintenance. And she's also asking about the size of the earth block.
Okay. The size of the earth block.
If you remember.
I actually have one right here. Give me 1 second. This right here, we have this at the office, and This was one of the first ones we did.
Okay.
You can see they're not quite perfect, but and this is 30 centimeters, and it has 10 centimeters high, and it's 30 across 15 centimeters.
Good, perfect.
Yeah, well, the thing is, for the maintenance part, we have done some maintenance of the house. We recommend it to do some maintenance. Mainly, hold on. Mainly, we have some sealing a bit from the outside. We have to do some minimum sealings. We have we need to this was kind of interesting because for the client to understand that the walls kind of breathe, and we needed to let them like have this normal breathing of the walls.
Okay.
So we needed we found this sealer, this that we apply that still keeps kind of the water to come in from coming in, but it lets the house have its own like kind of breathing.
Is it silicate that you were
Sorry?
using? Silicate? No.
No, it's another. It's
another. Okay.
It's another, but yeah, it has worked like it has worked perfect with it.
Okay.
And I don't know what other question.
You can read on the side, you know, in the text, but mostly it was this.
Oh, let me see. Let me see if I can. Let me see where can I.
Yeah, you can. Aisha, you can.
Oh, sorry. Here, I'm sorry.
Open your microphone for asking. It's also possible.
Okay, let me see what other question.
That's the last question. There is only one for now. I mean,
okay. So that's what we did, and the plaster of it was we did some as well. We did we tried different recipes of it because we wanted to. The first ones were to pallet, and so we actually added more earth to some of them, and basically what they had was earth and cal, which is
lime.
Lime, yes. We added lime and earth, and we mostly didn't add cement to these ones. We did another material. We added we added something else that was like give me 1 second. Lime. Oh yeah, it was like a small percentage of sand, and then the earth, and then lime.
Okay.
One of the worries I had was from this for this plastering was that I felt that it was going to fall. I felt that it wasn't going to last. That was one of the worries I had. But honestly, it behaved wonderfully. The sealer had helped a lot.
Yeah, I'm sure. There is Selim that would have a question. Please, Selim, you can ask.
Okay, actually, as I see, you used a column in your building. Am I right? Because there are some columns, and you use reinforcement in your building. If we design a building that it, have just one floor, and do we have to use again like this column, like the reinforced column? Can we just make it mood? And if we make this mood more rigid, and if we use it, can it be okay also in case of earthquake? Because
definitely.
If we were using only the earth block without any reinforcement, would it on only one floor? Would it be enough?
Actually, once we were like doing some research, we found out like quite many constructions with one floor that don't need that much reinforcement. Specifically, the house we just saw, we needed to add quite some reinforcement because of the elements and how the project was going to be, and it was 3 floors, and we had a patio and a garage and everything, and we have like very large I don't know how to say it,
Fun.
Yes, for elements to like float or to, and so that what needed in this case indeed. But for one story, for one floor houses, I think it doesn't need quite that much reinforcement. We saw some. There are some blocks that have 2 hollows. I don't know if you have seen them. That me pasas el otro block que tenemos. I'll show you this block I showed you was the one we used. This was the one we fabricated from the site. But while we were investigating, we found out another company that actually made earth blocks as well. Gracias. And they did this one.
Yeah.
As you can see, this one is more. It's more perfect than ours, and it has this hollow. And this holes sometimes they can you can use for you can add a rod here for different for even 2-story houses or something. You can add a rod, and it gives it reinforces very much the wall.
And I have like one more question. Sorry for that. And
yes,
actually, it is 2. I'm sorry, but if we make a 2 floor, we have to add some reinforcement. Yeah.
Yes. Yes, definitely.
And
I would.
In case of like fire, did you add any like chemicals to it because you used mud brick? You know, in case of fire and rain.
Well, no, we didn't add any chemicals to it. We believe, well, we were told, and from the as well from the research we did, it works very. I mean, from fire, what actually a friend was explaining that what do you do when you have a fire? You add earth to finish it. So it's a material that it's not it doesn't get combustion. So it works well with fire.
Okay, thank you so much for your presentation.
You're welcome. Thank you.
There is, if you want to read, I mean, there is Aisha that is also asking if you had to put a lot of effort to use this material, to convince people to be able to use this material.
Right here, I'm trying to. Oh, right here, yeah. I've seen it. Well, a bit, yes, but I mean, the client of this house was kind of there was kind of a connection once they understood the concept. They kind of fell in love with the concept of having a very efficient material, of using the ground to build their own house, of the sustainability part of it. And they were very happy about it. They were kind of scared about maintenance and and what would these things do. About structural, I gave them all the assurances that it would be no problem, because I knew it would be no problem, because we oversaw that with the reinforcements. But I think they might be some people that might be kind of skeptical about it. But even me, when I wasn't sure if I wanted to, I mean, I wasn't sure if I was going to like this was the first time I was working with this material. So from one part, I was telling a client there were going to be no problems at all, and the other part of me said, I hope I don't have to move out from Mexico anytime when when they have any problems. But no, I mean, so I mean, I was kind of skeptical at some part, but now that I've seen it work, it's amazing, and my clients are extremely happy. This is a house that they wanted to add it's a AAA house, so it had we added a a floor heating system, because they wanted to have that, and I think they have never used it. So they're very happy about it. They live they write me texts constantly about how they enjoy the house, and surprisingly for them as well, because I don't know, it gives like a sense of wellness, I think. So yeah, earlier, before I was telling you, at this office we work from different. What we have done, we try to do. We work with what we have, with the circumstances we have. I haven't done another house with earth blocks, because I haven't seen it hadn't come that opportunity. In that specific project, we had that kind of problem that we had to do with a lot of earth, and that problem we decided to turn it into a solution, which we believe worked perfect. It worked great. But and in other projects we work with different scenarios and with different things that we find. But I would definitely work with this system again.
Okay, that's good.
How long did construction period last? It took a year. It took a year. That part was I wouldn't say we lost time at the beginning, because we didn't find the correct recipe for the resistance we were finding. Because at the same time we were doing it, we were working with the foundations, but it took a while at the beginning. That was the point where it got to a bit stressing, because we had to run against time and space.
And if it would have been a normal construction, the period would have been more or less the same, or much shorter?
A bit shorter, I guess. Because, but also I have to say, this was the first time we used this system. So I could say, if I were to do another house using this system, I would obviously contemplate this period of finding the resistance of the specific site's earth, and explaining that to the client. I would say, well, it will take a month or two to find this. Okay. But while we do this, we can still work parallel to this on the site, which is what we did here. But Here we were like we were a bit more compacted.
Okay. Is there any other question?
Well, here is, did you consider another alternative for the structural system? Oh, well, sorry. You about the mastering system, can you check something that is called
No, this is not for you. This is for the students.
Oh, okay.
No.
Okay. Did you consider an alternative? Well, we didn't because what we did was once we had the concept and for the project, we had a meeting for the structural engineers, and so I was completely like open to see what we were going to do is structure wise, and they said I think that it was the only option for this kind of project. They said we had to do reinforced concrete for this. They didn't want to try something else, so I just went with them.
Okay, thanks.
I have a question.
Yes.
So Mexico has this earth building tradition from the many age, and
yes.
so this traditional way is like sun-dried and with using straw or other fibers. So you want to use next projects traditional mud bricks or earth blocks, or will you continue like stabilized earth blocks in your future projects?
Well, I would love to work with different techniques. I'm very fond of traditions, and each time we would in each site or in each new project we receive or we get on the table. One of the most important parts for us here at the office is to look at to understand its history and to understand its place and the context in different points of views. How are we affecting the site, but how we are affecting the neighbors? How are we affecting the local place and the global place as well? And but yes, we more and more interested in working with what was used to do, with the roots of things, with the we're working right now on a house in Cancun, here in Mexico, and we are probably going to work in Tulum as well, and that would be a great place to work with straw and work with bamboo and work with other techniques, which I think are great and I think are the best solutions for those places. But to answer your question, yes, I would love I would love to keep investigating and trying new things, and I mean trying new things, but they're really old things, and I think those old things are much better answers to some cases than regular construction systems.
Thank you.
You're welcome.
Thank you for the presentation, by the way. And I want to ask about the Gremelville House project you are working on right now.
Yes.
You said that we are using white clay.
Yes.
You earth brick, is it the same?
My
like earth brick, but I think it's different.
Oh well, well, it's actually that house has as well has we brought for doing that house we found out we wanted to use a white block And we saw, for us, it's important to work with local materials. For us, it's very important. We try to find the most local solutions for our clients, for all our projects. So in this case, we saw that we found out, we saw that there were some in Spain, and we saw some other materials in other parts of the world, but it was very expensive to bring them here. And then we found this white clay was being done in Puebla, here in Mexico, which is not that far from the city of Mexico. And so we went with that. We did some testings, and the structural part is also well, it's kind of different, because let me see what the let me tell you the system is. So the ceilings of that house was made with joist and bolt. I don't know if you have heard the term, but it's a mixture of lightweight structure for most of the ceilings, and it's combined with reinforced concrete as well, with reinforced elements, but they're not as many as the ones used at Cumbres house, because in here we had we had different elements. Grimaldi's house is mostly one store, and just one part has two stores, but two stories, but it was kind of the same structural solution, with lighter elements. I can show you some pictures if you want, but
maybe you say. Okay, so you are using reinforced concrete columns again in this project.
Yes. Right. Yes.
Maybe I missed the part of the presentation that you talked about the cracks on the reinforced columns. What did you do after you see that? I mean, that you said something like that we decreased the space between the columns, between the walls. Maybe, is it true?
Yes. From the first walls we had, the separation between columns. This castles, we call them castles here in Mexico, castillos. They're like a small column, which is mostly 15 per 15 centimeters, and these are not that reinforced, but they like structural elements that go at every sort of distance in the walls, and so what we found out was we had like a space between two of 3 meters. And once we saw that we were getting some cracks, right at the middle of the wall, between both elements, right at the middle, like exactly at 150 meters distance, we would get like a small crack that would go from one side to another. And so I called the structural engineer to the site and said, what can we do here? What's this? And I did some research as well, and I found out that this was happening in some other places. So the recommendation for the structural engineer was to close the distance between these columns, these inner columns, and that we did. We didn't close it that much. We came from 3 to 2 meters, and so we had to add some more structural elements that we were considering, but the house, other than that, it behaved real well.
Isn't it constant that you used the dimensions of the columns? Isn't it constant when you started the project? Isn't it exact that after you decrease because?
Well, the thing is, once we have the project agreed and approved by our clients, then we meet the structural engineers and we work with them with these solutions. And the structural engineers, the structural part gives us a structural project that has some of these, that has the most important elements. And then there are some walls that they say, like, you could add no structural element here. I don't mind. The house is not going to fall. I mean, it's not going to affect the structure of the house. So in that sense, that's where we knew the structure wasn't going to be compromised at all. But since we saw this static thing happening to the material, closing or adding more structural elements just became something to add, to not to move the structure project, but to just to fix the static part of it, of the project. I don't know if that answered, or if I didn't answer your question.
You said that it is not important so much. So we started the project randomly, not totally randomly, but I get it. Okay.
Yes, well, I mean, there are some parts of the structure project that are open for I mean, for these additions, I guess, and they don't compromise the structural part of the house. He see the structural engineers see more that the house will stand, the house will take the minimums or for earthquakes, and other than that, there are some parts of the project he will tell me, like, he'll tell us, well, right here you could add 2 columns or 3 columns if you need it, but they're not needed for the structure. If you could add them if you need it for the material of your walls. I don't know if I've made that clear.
Okay, thank you.
You're welcome.
Is there any other question? Okay.
I want to ask something, if you have time.
Sure.
First, I want to say thank you for your presentation. What confused my mind was about the structural system, the way you built the structural system. As our instructor said at the beginning, here in Turkey, we use a kind of opposite way while we design or build the structural elements. Especially after the earthquake that happened here, we as students, we made lots of research about this structural system and the infill walls and the relationship. And as I remember, in one of the seminars that I watched, or the instructor said that it should be the structural system and the infill walls should be separate from one another to have a much more healthy construction system, or for let's say a much more resistant system completely. And he said that directly attaching the infill walls with the columns is a kind of a negative thing in terms of earthquake, but the technique that you use allows the concrete of the structural element to infill the small brick gaps. You said something like that. You said that with this technique, the concrete fulfills the small brick gaps. And I wonder how it can be stronger like that, because in one seminar I watched and I heard that it should be separate, walls and columns. Especially the person said that it should be a little gap in between those systems, but the building that you designed work perfectly, isn't it a disadvantage to have them so much connected?
Yes, I think. Let me explain myself a little more. The structural part of the house, to explain the main structure of the house works independently and with from the walls. In that sense, it's not that they're attached. They're just right there, built one by one another. They are since we add the clay, the plaster. It looks like at this. It looks as they work as ones, but structurally wise, they're not working together. Where we added these columns and we poured the concrete, and where they are like more connected, it's the small the ones that we call castillos, castles, the small ones. These actually are what these are doing. These are actually keeping the wall, one panel from another, together. These are doing that. I don't know if that is the best solution, but that's how it worked for us. But the main structure, it's not that much attached to it, and actually the structure engineer explained to us that they were going to, in a movement, in a ground movement, it was going to move. Some parts of the house were going to move different than others, but the walls, the large walls we did, those are quite connected, and also he explained that we could be expecting, since some of the parts of the house weren't, the structural elements weren't that joined, that connected, we would expect to see some cracks for the plaster, and that's why it helped a lot for us to make those separation in the plaster. But in some of the walls we did pour the concrete, and I feel it keeps them together. So far it's been so good in that sense, but I think that's why the engineer explained that the main structure works separate from other parts of the house.
Okay, I get the point. It confuses my mind because here we learn just we design just one construction system, one frame system, and it is the whole thing for the building. You talk about something much more interesting, like we have a main structural system in the design and some supports, but because here in Turkey it's a little bit different, it confuses my mind. I suddenly think that it's the same, and it was the single system. I thought, okay, I get it right now.
Actually, I'm going to show you a picture real fast, because it was a bit confusing. It was a bit confusing to me during the construction work, because let me see if I can find it here. Right here, this element right here, this structural element right here is, I mean, this slab of concrete, I was sure this is like 12 centimeters reinforced concrete right here, the floor for this upper part of the house. And I didn't understand why the structure engineers didn't want me to relate. I mean, there aren't any metal rods going up from this part to the upper part, saying that the structure that comes here is carrying it's supported by itself, and this slab right here is not carrying these walls. These walls they're hanging from this one up here. I don't know if I make myself clear.
Okay, yeah.
So it's a kind of a structural solution. So those are the parts that I mean, you can see them, they're together, but there are not any structural metallic rods that connect this structure with this reinforced slab right here. So that's one of the things, combining these structural solutions. And also in this case, we did only reinforced concrete, but there are some other parts for example, in Valle de Bravo, we worked with metal structure as well as with with rock. We work with rock and on the walls, and as well as metal, and as well as some concrete reinforced elements. So we've been working with different kinds of structural solutions on one same project.
Thank you so much. Very inspiring for us students.
Thank you.
Anyone else wants to ask something? Because I think it's already 1 hour and a half that we are speaking with Sergio, and probably he might be very busy and having other work to do. It's very nice.
No, I'm happy sharing with you.
Okay. It's really nice from you to take this time, because as Shukran just said, it's really inspiring, because seeing different construction technique and seeing some possibilities that students are not used to see here in Turkey, neither in their education or in the projects they can see around, is something really interesting. So, because it's not always easy to travel around the world to see different projects, it's good when people can come and share it with us. So thanks a lot for it.
No, thank you. I'm happy. Thank you for the opportunity and for the invitation, Matthew. And thank all of you who are watching the presentation. Thank you very much.
Okay, so thanks a lot for everything again, Sergio. And if you want to add, or if you have anything to share with us, we can still be in contact, or you can.
Thank you very much. Please, anything you need, just let me know. And I'm just happy I could share some of our experiences. I mean, as you know, we're all young, and we don't know everything, but we're trying. Specifically here at the office, we're trying to learn every day more things, to experiment every day more things. So I would say not to be scared of trying new things. That's what that would be my suggestion, specifically for this kind of materials, of construction solutions. The easiest way would have been on that house to do it just with regular construction systems, and but we wanted to do something more. We wanted to add some value to the site and to the place, and we wanted to experiment with the earth. We found it kind of romantic as well, and I think when you go further and try to risk a little, the results are very gratifying.
Thanks a lot. And yes, the result is very beautiful and very inspiring. So thanks again, and wish you a good day, since the day is starting for you. And
yes, thank you. Good night. Good night over there, I think.
Yeah.
Good night for you guys.
Thanks a lot again, and we stay in contact. Bye-bye.
Thank you, Matthew. Thank you. Thanks for everyone. We'll stay in touch.